Cool guys, so today we are going to talk about probability and expected values. So we'll be discussing the topic in brief first. So I'll be giving the basic idea about probability and expected values. Then we'll discuss two questions, one from Codeforces and one from CodeShift. The level of the problems would somewhere be in around 1600 to 2000. This is as per Codeforces. You can add maybe like 300 or something onto this if you want to check for CodeShift. Cool. So let's get started with the basic concepts first. So what is probability? So that's a concept we already studied in school. So probability basically means how likely is one outcome. So if I give, let's say I give you like 10 balls in a bag of different colors and I ask you to choose a ball, right? So I'll ask you to choose a ball and let's say there's one ball of red color, one ball of blue color, so on and so forth, right? There are like 10 different colored balls. So what's the probability of getting a red ball out of the bag? So it's basically 1 by 10, right? So how do we get this number? This number is basically 10 is the sample space and 1 is the outcome we want or our wanted outcome, right? That's the basic of probability. Now the point is, where does this expected value concept comes from? So the best way to understand this in my opinion is that we all know about betting and stuff, right? So let's assume that you are trying to take a lottery, right? And let's say that lottery has maybe like 1,000 tickets. Let's not calculate that what's the value of each ticket, but let's say that there are 1,000 tickets in total, and the lottery person announces that the winner of this lottery, so there would be one winner only, right? So the winner of the lottery would get like let's say $1,000, and the runner-up would get let's say $50, and maybe like the second runner-up would get $10. Now, if I ask you that, let's say you take a lottery ticket, so what's the expected value? Now, what would that mean? That would mean, on average, what is the value that you're going to get out of it? So this becomes an important concept, right? If you're taking a lottery ticket and if you're able to predict that what is the value you're going to score or what is the money of amount of money you're going to make out of it, that becomes an important concept. So how would you calculate it? So we'll say what is the probability of you getting $100? So since there are 1,000 tickets, so the probability of getting $100 is 1 by 1,000, right? What's the value of $100? $100 value is actually 100, right? So we'll multiply it by that. Then we'll say, what's your probability of getting $50? That's also 1 by 1,000, right? We'll multiply it by that. Then we'll say, what's your probability of getting $10? That's also 1 by 1,000 because one person will only get $10 or $50 or $1,000, right? And then we'll add them. So we'll add them and we'll get 0.1 from here, 0.05 from here, and 0.01 from here. Once we add them, we'll get 0.16. So if you buy this lottery ticket, this is the average value of money you're gonna make. How is this helpful? Now let's say if the lottery's ticket was actually of $0.15, right? Then it is a fairly good idea to buy the lottery ticket because at least you're going to make that much money. Now it's not a surety that you're always going to make $0.16. It could be that you make like maybe $0, right? Or make $100. So basically there are only four cases over here. So either you'll make $0, you'll make $100, you'll make $50, or you'll make $10, right? So how do we come up with this particular number? This would happen on average, right? And that is what the expected value is, that this is what you should expect if you are going to buy this ticket or if you're going to register for this event. This is the thing you should be expecting. So this is the concept of expected values, or more formally, we can write it as E of X, right? Or expected value of X is equal to whatever X is, like over here, X was 50, 100 and so on. Whatever the value of X was multiplied by the probability of X, right? We want to make break down this further. So you can say whatever the value of X is, like just let's write it like this, multiplied by the occurrences of X divided by the total sample space. Now there's one very, very important theorem in case
Can you explain that part again?
Which one?
The function of E.
The function of?
EX part. Can you explain that formula?
I didn't get you. So you're talking about this?
Yes.
Okay. So over here, we said expected value of X, right? So over here, what was the expected value of getting 1,000? Or basically whatever the value of a particular thing is, that over here like the value was 100, right, of getting $100. If you get $100, the amount of monetary gains you make are 100, right? So 100 multiplied by the probability of getting $100. So what was the probability of getting $100? That was 1 by 1000. So that becomes the expected value. Make sense?
Okay, okay.
The only reason I'm like tightly coupling this concept with this particular example is because it's easier to understand, right? And if we break this down further, so it's value of x multiplied by occurrences of x divided by total sample space. This in totality is probability, right? So that's why I wrote it this way. Now, one of the most significant or most important formulas in case of expected value is E of x plus y is equal to E of x plus E of y. Now wait a second, what does this mean? Now this particular basically means that, let's say you want to calculate that what would be the expectation of having x plus y. Then you can simply write it in this way. Yeah, examples would definitely make it more clear. But the thing to note over here is that x and y need not necessarily be independent or dependent events. Even if x and y are dependent events, we don't care. We'll simply say that E of x plus y is equal to E of x plus E of y. Now this thing is crucial, and this will definitely become more clear maybe in today's session, or maybe into next session when we'll be discussing more examples that are based on it. But today I don't want to make it an overkill. So I just want to discuss this concept maybe in a bit brief. So up till this point, everything is clear.
Yes.
Okay, so okay, cool. So now what we'll try to do is we'll try to go through a question, and then we'll try to understand that how to build the intuition for this or in such kind of questions, right? So let me go through a question from Codeforces, and this is the question we're going to go through. So this is a 1600 level question, but I really believe that this should have been rated a bit higher because it also includes probability, expected value, and then it also includes your intuition and constructive algorithms, right? So the problem states that Twilight Sparkle was playing Ludo with her friends Rainbow Dash, Applejack, and Fluttershy, but she kept losing. Having returned to the castle, Twilight Sparkle became interested in the dice that was being used in the game. The dice has M faces. So these are the scenarios you need to focus on. It has M faces. So generally when we do a mathematical question on dice, most of the time it has 6 faces, right? But over here it can have M faces. The first face of the dice contains a dot. The second contains 2 dots, and so on and so forth. So that's obvious. I need not read that aloud. Then Twilight Sparkle is sure that when a dice is tossed, each face appears with the probability 1 by m. That means the sample space is homogeneous. So if you roll the die, the probability of getting any number on that is basically 1 by m, right? Also, she knows that each toss is independent from others. Help her to calculate the expected maximum value of dots she could get after tossing the dice n times, right? So in this problem, let's say you have a lot of experience with expectation and probability, then you will be easily able to derive the formulas, right? But the entire reason I'm taking the session is because you guys don't have, and neither do I, have a lot of experience with expectations, right? So we'll try to come up with the formula, but in a more intuitive and gradual process. So let's say instead of m, let's give it some value. So general like die has 6 coins. We don't even want to take 6. Let's just take 4 for that matter. So we have a die that has 4 sides, right? Yeah, that would be an unusual die, probably a tetrahedron, but let's just assume that our die has die with 4 sides, unusual die, right? So it has 1, 2, 3, and 4 other numbers on it. And over here they're telling us that we'll roll it n times. So for now, let's just consider we are rolling it for like maybe 2 times, right? So just so as to get the basic gist of it. So if we roll a die of 4 sides, where where the die has we are rolling it for n times, right? So what do we need to calculate? We need to calculate the maximum expected number of dots that she could get after tossing the die n times. So let's try to write down the sample space. Cool. So what would be the sample space for this? So let's say we are saying that n is equal to 2 and m is equal to 4 over here. So this is the number of rolls, and this is the faces on dice, right? So you'll say that, okay, in the first roll you can have a 1, and in the second roll you can have a 1 also. we are gonna iterate over all the possibilities. So let's write down all the possibilities. Then you can say in the first roll it's 1, and then in the second it's a 2, then first 1, second 3, then first 1, second 4. So we are going for up to 4. Then it can be that in the first case itself you got a 2, in the second you got a 1, then a 2 2, then a 2 3, right? So on and so forth. And similarly would be the case for 3 1 3 2 3 3 3 3 4, and the 4 1 4 2 4 3 4 4, right? So let's just write a bit more, maybe 3 2 3 3. Like rest is obvious. So we can also populate this, or we can talk in terms of a table maybe, right? So this table would be of this is 1, this is 2, this is 3, this is 4, 1 2 3 4, right? Now what are we able to observe over here? Now I know that we are talking about two roles only, but let's try to observe the scenario that's happening. So over here what's happening is we are asked to calculate the maximum number we get, right? So what's the maximum number we are getting over here? So for this sample it would be 1, for this would be maximum of 1 and 2, that is 2. For this also it would be 2, for this also this would be 2, for this it would be 3, for this it would be 3, for this it would be 3, 3 over here as well, 3 over here as well. This it would be 4, 4 over here as well, 4 should have been over here as well, 4 over here, 4 over here, 4 over here, 4 over here as well. Cool. Up till this point, any confusions?
No.
Okay. Now, if I write this down again, right, just for more clarity. So this actually is somewhat of this sorts: 1 2 2, 3 3 3, 3 3, 4 4 4 4, 4 4 4. Are you able to understand, or are you able to see a pattern onto this? There's a very, very clear pattern. So the number is actually appearing in terms of cubes, right? Or in terms of square boxes, you can say. And it is appearing in such a fashion that, let's say, how many times 1 is occurring? So 1 is occurring only 1 time. How many times 2 is occurring? So 2 is occurring 2 square minus 1 time. 3 is occurring 3 square minus the value for 2 and the value for 1, because 3 square would represent this entire box, right? This entire box would be represented by 3 square. We need to subtract the squares for 2 and for 1, right? Or this particular square we need to subtract. So basically the current number minus the value for the previous number, right? That is what we need to do now. So the scenario now is, how would we even do it? So that's the question we want to find. Also over here we have to generalize it. Why do we need to generalize it? Because over here specifically talked about of die with 4 faces and 2 was the number of rolls, right? So if I want to generalize it,
sir, n square minus n minus 1 का whole square, n square minus n minus 1 square.
Yeah, right. So you're right, exactly, you're right. But let's just try to write down your formula.
We can also use the current sum.
What?
We can also use the current sum variable.
Current sum variable?
Yes.
What do you mean by that?
1 plus 3 will be 4. And
Yeah,
next
yeah,
will
yeah,
be
Yeah, you can use that. But we have to write down in a more generic way, because over here n can be anything, right? So that's why we have to write it in a more generic way. So how can I make this more generic? So I can say the occurrences of I is basically the occurrences of I minus 1 plus 2. This is happening over here. So occurrence of 1 is 1. The occurrence of 2 is 3. The occurrence of 3 is 5. The occurrence of 4 is 7, right? That makes sense?
Yes, sir.
Or another observation is that the square, so over here we are talking about squares because n is equal to 2, right? So observation could be that for the ith element, the entire square, right, is I squared. So for 2 we were having this entire square, that was this, right? So this was of size 2 squared. This was of size 3 squared because this was of size, this was of the element 3, minus I minus 1 squared. Cool. This is something we can do. Now if I try to generalize it, so instead of square we'll be taking n, right? So this would become I to the power n minus I minus 1 to the power n. Cool. What is now the samples? What is now the total sample space? So over here we said that okay, m is 4 and n is 2, so we got 4 into 4, that is m into m, right? we multiplied it n times. So that basically means m to the power n, right? Also, the important thing now is that we have to multiply it by the value we are getting, right? So for this I, the value is actually also I, right? So when we were calculating this, okay, it's getting too messy. So when we calculated this, we said that the value is I, and we already discussed in case of probability, we need to multiply the entire thing by the value itself, right? So I can say I into I to the power n minus I minus 1 to the power n divided by m to the power n. Is this cool? Understandable, or any doubts in this?
So there is some message in chat box.
Okay, let me see. Sir, I minus 1 के आगे summation भी होगा ना? Yeah. Okay, so it's not about summation. I minus 1 के आगे summation नहीं होगा. The reason being, okay, I got your doubt. Okay, look at this. So we are talking about the ith term, right? So for the ith term, the 3 has actually n boxes, right? Or the square of this is actually n, right? The inner square actually is 4, right? Or the square of 2 is actually 4. We can directly subtract from this and we'll get the actual value that, okay, yeah, we can actually get the value 5 from it itself, right? So it's not summation. Make sense, Shubham? Cool. Let's get back to the scenario. Okay, got it. Cool. So let's get back over here. Let's try to understand that how we'll code it up now. Now actually the formula is already here, but now you'll say that why are we even bothered about calculating it? It's simple. It's actually not. The problem is that over here, I can go up to 10 to power 5, right? So technically when you're calculating something like 10 to power 5 to the 10 to power 10 to power 5, it's gonna be a big mess, right? And you'll get an overflow and the answer is gonna be wrong. The trick, however, is that since the base over here is m to power n, so you can write it as I into I by m to the power n minus I minus 1 to the power n divided by m. Make sense? And over here, this is not actually simply, and this is some expected value of I, right? Or you can say occurrences of I. So yeah, occurrences of I minus 1, occurrences of I minus 1, occurrences of I minus 1 to the power n. You can write it in this form. The benefit from this is that I divided by m would always be less than or equal to 1. The max value it can have is 1. So because it's less than or equal to 1, we get values in the floating point. And whenever we are having questions that require the values in the floating point, we always have a precision error that is acceptable. So the question would always state that the answer should be in the within the ranges of 10 to power minus 5. For example, if you print the answer as maybe like 325100, right? And even if the answer is like 325103, right? This would be accepted as the correct answer. So there's a scope of having errors within the set precision. So that's why this becomes important. Now let's try to look at the code, or how we'll code it up. The code is, I'll say, fairly simple, but still let's just have a look at it. So this is the code I coded today. So over here, what I'm doing is I'm taking the two values, right? After that, I'm going from m. So for each of the faces, right, I need to calculate it. So I'm saying the probability, current probability is I divided by m to the power n, right? So that's the basic power function that STL gives us, or that C++ gives us. So I divided by m to the power n. Then I'm saying result would like we are gonna do a summation over all the values, and we're gonna multiply this value by I, right? So coming back over here, so this basically means that I is getting multiplied by the current value minus the previous value. Now initially the previous value would be 0, right? So we'll say result is equal to result plus this entire value, that is I multiplied by the current probability minus the previous probability, right? And then we'll set the previous probability to the current probability, and we'll keep iterating it, and then we'll simply print the result. So yeah, in these kind of problems, the code is most of the times fairly small. It just requires intuition to come up with the solution, or to come up with the mathematical formula that is required. Any doubts so far? True bro, Sarkari brute band. Yeah, that's why it sucks. Anyway. Okay, wrong sticker. Okay, so any doubts so far? Everything clear?
Yeah.
Okay, cool. So let's jump to the next problem. This particular problem is too very heavy on intuition, I'll say. So it's not like it's a very complicated problem, but yeah, it's heavy on intuition. So the problem states that you are given a bag containing n balls numbered from 1 to n, each having a given non-zero integral volume, right? So you should imagine that you are having a bag, and into that there are balls with different volumes, and each ball is like having its own volume, and you know that. So the likelihood of a ball being taken out of the bag is directly proportional to its volume. So the more the volume is of that ball, the more handy it is to pick that ball out of the bag. So now you are bored and you decide to play a game. It has n rounds. In the ith round, you want to find the ball numbered I, right? To do so, you take out the balls one by one without replacement till the time you get that particular ball numbered I, right? And then your round would end. Then you'll keep all the balls back into the bag again and would proceed for the next round. So basically that means in the ith round you will be looking for the ith ball, right? And to get the ith ball, you don't know where the ith ball is currently, right? So it's like a black box kind of a scenario. So you'll keep picking balls out till the time you get the ith ball. So we have to tell for the ith ball how many number of balls would have been picked, right? So formally what they're stating is, you need to find for each round what is the expected number of balls you would need to remove. So that is what it states. So is there any problem in the problem statement? Everything is clear? Any doubts? So I'll
Yes, sir.
okay, cool. Okay, so what you can do over here is that initially this problem might actually seem tough, right? That how we'll do it, because every time in every round we have to compare it with the other balls, right? Looking at the constraint, n-square logic is definitely valid over here. I don't even think there's a better logic available. So n-square has to be the scenario. But how would you compare the balls? So this is about reference points. So what actually is happening is that, let's say in the ith round, right, you'll be having several balls. So there would be balls from 0 to I minus 1, and there would be balls from I plus 1 to n. Now I'm not even talking about the volume. I'm just talking that there would be balls. They could be randomly arranged. I'm not worried about that. So yeah, some big balls, small balls, big balls, small balls, big balls, anything like that. Okay. Now what I'll say is that the probability of any ball being picked is directly proportional to its volume. So P of I is directly proportional to V of I, right? However, I'm only concerned about this particular ball that is at the location I, right? So the probability of the jth ball being picked, let's say j is anything from 0 to I minus 1 or from I plus 1 to n. So basically j is anything but I, right? So the probability of the jth ball getting picked would only be decided by the ith ball. Or more formally, I can say that the probability of the jth ball being picked would actually be the volume of ball j, volume of j divided by volume of I plus volume of j. This makes sense? Any doubts in this?
सर वॉल्यूम ऑफ आई क्या है सर यहाँ पे?
Okay, so we are talking about the ith ball, right? In the ith round, we need to see that how many balls are being picked before we see the ball I, right? So that's the volume of I basically means the volume of the ball I, and the volume j basically means the volume of the ball j. Cool?
Yes, sir.
Since being picked is directly proportional, yeah, right. So
Okay.
that's why the biggest ball, right? So yeah, so the biggest ball would be having the highest value over here. So for the biggest ball, this value would be big, right? So this would increase for the biggest ball, and hence its probability of getting picked would also increase, right? So yeah, this is the thing now. Now we already know the probability, but we said that the expectation value is actually the probability into the value it's gonna add to our score. So what should be this particular value over here? So that would depend on what we are trying to find. So we are just over here trying to find the number of balls that are being picked, right? For any ball, the number of balls is exactly one, right? For a ball I, if I pick that, how many balls I'm adding to my answer? I'm definitely adding just a single ball. So I'll do one over here. I'll write one over here. Had they asked me something different, that let's say ball has some scores and you have to tell the expected value of that score, I would have written scores over here. Or had they said that okay, score of j over here, had they said like you need to print, you need to tell us the volume of the expected volume of the balls being picked. So over here I would have written volume of J, but they simply are asking me the number of balls that would be picked, right? So in order to calculate that, I can simply state that the number of ball, if the jth ball is picked, the contribution of it to the number of balls is actually 1 itself, right? So I'll say the answer basically is, I'll start a loop, right? From I is equal to 0 till I is less than L, right? Then I'll start another loop. Let's say J is equal to 0 till J is less than N, right? I'll just have to check that my I should not be equal to J, right? If my I is not equal to J, then the answer exists. And what's the answer? Or like if I is not equal to J, then I have to compare the ball J with the ball I. So over here, let's initialize result to 1, right? Why I'm initializing it to 1 and not 0? Because in every scenario, I'm definitely picking the ball I, right? So ball I is being picked, its value is 1. Over here, I'll say the probability of a ball, the probability of the ball jth being picked would be, it would be 1. That is the score it's gonna add to my expected values, multiplied by volume of ball J divided by the entire volume, that is V of I plus V of J. Make sense? And this value needs to be added to my answer. So the answer is being defined by res. So I'll set I'll increment this value in result, and then I'll print this value. Okay, res. Let's try to code it up. Any doubts in this? Okay, cool. So let's try to code it up. I already have the code written, but let's just do it once again if you want that. But one thing I want to tell you, it's not related to this particular problem, but just related to platforms per se. So when you're coding in Codeforces, right? And even if you're not setting this precision, so they'll just check for your answers. They'll trim the leading zeros or whatever you want to call it, and they'll just check for the final value of your answer. And if that is correct, they'll give you AC. However, in case of CodeChef, they specifically check that if they've mentioned that the number of zeros should be 9, or the number of digits after the decimal point should be 9, then they exactly check for that 9 digits. If you mess up over there, so they'll give you a WA or a wrong answer. So we are just specifying that 9 digits. Okay, post the decimal point. Cool. Then what we are doing is we are going for all these values from I is equal to 0 to n. So this is for the ith round. I need to consider the ith ball.
एक पॉइंट जोड़ कर दो, मतलब एक दो स्टेप.
Sure. Fine now.
Yeah.
Okay. So like I already told you that you need to set the precision. So you are gonna say that I'm gonna print 9 digits post the decimal point, right? Or post the decimal point, and then you say that for the ith round, I need to consider the ith ball, right? I need to compare all other balls with this ith ball. I'll do that. So rest would be set to 1 as I explained, and then you'll check for all the balls. So if J is equal to I, that means you cannot just compare the current ball with the current ball itself, right? That's obvious. So you'll continue over that. But if it's not if it's not equal to I, then you need to check what's the probability of this ball being added to your bag. So this is the probability, that is V of J divided by V of I plus V of J, right? And then you're going to multiply it by 1.0. That is the score it's going to give you, right? So if you're picking this particular ball, right, then the number of balls are just increasing by 1. So you will multiply it by that, and finally you print the result for every round. So this is its code. If you want, I can just show you by submitting it. Okay, I'll have to submit this in practice. Okay, we get a correct answer for this. So yeah, that was it for this session. I just wanted to be brief about it and not to make it too very complicated to understand. I hope the concept were clear. So did you guys learn something from this, or was this concept a bit tough to understand? What's your take on this? And before we do that,
सर पहली बार रिवाइज करने को मिला एक्सपेक्टेशन.
मुझे दोबारा वीडियो देखना पड़ेगा थोड़ा सा समझने के लिए.
Okay.
सेकंड वाला क्वेश्चन.
Sure, bro. I'm actually gonna upload this, right? So it's gonna get uploaded probably by tomorrow, and then you can watch it. Cool, Monkey King. Guys, I really hope that you guys actually tell me, like, rather than complimenting me on the videos, you actually tell me where I'm lacking so that I can make better content. So the only reason I'm making all of these videos is just to help you out. So if I'm lacking somewhere, definitely point it out over there itself. Anything else you want to understand over here?
No, sir.
Cool, I'm gonna close the